This is my trigonometry course. Today we're going to evaluate composite trigonometric functions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. I want you to get a picture of these pages. You're going to need these range restrictions for the inverse trigonometric functions right in front of you as we work along today in the class, and also the graphs of the basic trigonometric functions. And you should know this information pretty well by now, but just in case you're a little rusty, go ahead and take a picture of these pages. We have the basic information we need, special right triangles, and the 6 basic trigonometric functions. Today we're going to find the value of expressions like this, and we're going to find the values without a calculator. Now this is called a composite expression because we have a function, a trigonometric function, inside another trigonometric function. So it's made of multiple parts. It's composite. And these problems are a little intimidating, and for that reason we're covering this at the end of the course. I didn't want to bother you with these problems until now, but even though these problems are a little intimidating, you'll find that with a little practice they're not going to be so bad. Now the most important thing to know today is we're going to start by finding the value of the inside expression. That's the way it's going to be for every problem today. We're going to start by finding the value of the inside expression. The problem is we don't know what this notation means. So to help us, we're going to set that inside part of the expression equal to theta. Now remember, when we solved equations like tangent theta is equal to 1, if we wanted to find the solutions using a calculator, we would enter this notation into the calculator. We had this button here. So this is just notation that we use for calculators if we want help to find the angle measures. Well, now we're going in the opposite direction. We're going from here to here. Usually we have an equation and we then use this notation to find the angle measure, but now we're going in the exact opposite direction. We want to find this value, but we're not really sure what that means, so we convert, and now we can see that we're just looking for the angle measures that produce 1 when we put them into the tangent function. So we need to find those angles. So I'm going to draw some triangles, and I know that tangent is positive 1 when the angles terminate in the first and third quadrants. Now 1 is a special ratio. That's x over x in the case of tangent. So we know that we're dealing with a 45, 45, 90 degree triangle. And I know that the triangles are in quadrant 1 and 3 because x divided by x is positive 1, and negative x divided by negative x is also positive 1. And because these are 45, 45, 90 degree triangles, I know the reference angles are 45 degrees. So one possible angle is 45 degrees, another possible angle is 225 degrees. So usually when we're solving equations like this, we're looking for the solutions between 0 and 360. So we have 45 degrees and 225 degrees. But we're not looking for the solutions between 0 and 360. We're just looking for the value of tangent inverse 1. And when you're looking for the value of this expression outside the context of an equation, because again, we're not starting with an equation. If we were starting with this equation down here, then theta would most likely be more than one value if you're looking for a certain range of values. But we're not starting with an equation. We're starting with just an expression. We want to find the value. So it's considered to be the output of a function, and a function can only have one output for every input. So we go to our tangent inverse range restrictions, and we see that tangent inverse has to be between negative 90 and 90 degrees. So we're going to cross out 225. So tangent inverse of 1 is equal to 45 degrees. That's what we're looking for. So we found the value of the inside part. Now, you don't have to draw these triangles. You can actually do this in your head if you want to. So part 2 of the problem is to find what we're actually looking for, is sine of tangent inverse of 1. We found that tangent inverse of 1 is 45 degrees. So now we're just looking for sine 45 degrees, and that angle is in the first quadrant. And we see that this is a 45, 45, 90 degree triangle. And sine is the opposite side of the reference angle divided by the hypotenuse. And the x's cancel out. And we're left with 1 over root 2. And if we rationalize the denominator, multiply both sides by root 2, and we have the following. So there you go. So I know that seems intimidating, but if you have this information in front of you and the range restrictions on the left, remember we have the tangent inverse range restrictions between negative 90 and 90, and memorizing the shapes of these graphs will help you so that you don't have to constantly go back. If you have all that stuff in front of you, then this won't be so bad. So let's try another problem. Again, the most important thing to remember today is when we find the values of these expressions, we start by finding the value of the inside part. Again, if you forget everything else we talk about today, remember that. Start by finding the value of the inside part. But we don't know what this notation means. So in order to help us understand what it means, let's set the expression equal to theta and then translate that equation to a different form. Now we can understand what this expression is asking us to do. It's asking us to find the value of theta that you can plug into the sine function so it equals 1/2. So we're used to using this notation on our calculators, but if we see this notation, we can go backwards to understand what it's really asking. So we want to know the theta values that work in that equation, and I know that if sine is positive 1/2 in this case, if it's positive, then the triangles have to be in the first and second quadrants. And the reference angles are going to be 30, and sine is opposite over hypotenuse, so the opposite side has to be x. That represents 1. And the hypotenuse is 2x, and obviously the adjacent sides are negative x root 3 and x root 3. So notice that the opposite sides are positive, and that's why the triangles are in quadrant 1 and 2, because the hypotenuse is always positive. So if the ratio 1/2 is positive, then that means the green opposite side must be positive. So that's why we have these x's that are positive, and the triangles are in the first and second quadrants. So theta is going to be equal to 30. That's the angle in the first quadrant, 30 degrees, but we also have an angle that terminates in the second quadrant, 150 degrees. But remember, sine inverse has range restrictions. If you look at those range restrictions, you see that the values of sine inverse can only be between negative 90 and positive 90. You can see that by looking at the graph also. So 30 degrees is going to be the only angle measure that we're allowed to assign sine inverse 1/2. So we're done with part 1. We found the value of the inside part, this yellow inside part. So now we're going to find the value of secant of sine inverse 1/2. So sine inverse 1/2 is 30 degrees. We just found that in the previous part of the problem. And now we just have to find the value of sine 30 degrees. And opposite 30 is x, and the hypotenuse is going to be 2x, and the adjacent side is x root 3. We recognize this as a 30, 60, 90 degree triangle. And so secant is the hypotenuse divided by the adjacent side. The x's cancel out. And then we're going to multiply both sides by root 3. And there you go. So the value of secant of sine inverse of 1/2, the value of that expression is 2 root 3 over 3. So let's do a few more of these problems before you try one on your own. Again, the most important thing to remember today is you're going to start by finding the value of the inside expression. The problem is we don't know what that notation means, so we're going to set it equal to theta, and we know that you plug this, or you use this notation when you're looking for the angle measure in an equation where cosine theta is equal to -1. So what we're really looking for is the angle here, and we can draw triangles. Actually, that's going to be a collapsed triangle now that I think about it. When cosine or sine are equal to 0, -1, or 1, it's a collapsed triangle. And when tangent or cotangent are equal to 0, it's going to represent a collapsed triangle. So you have to go to your cosine curve and ask, where is cosine going to be -1? So look for the points that have y values of -1, and that's this point here, this point, and this point. So which one do we choose? We're only allowed one. There's range restrictions for the cosine inverse curve. This is the cosine curve. We're just using it to help us find the angle. But if you look at the restrictions for the cosine inverse curve, the restrictions tell us the value of cosine inverse has to be between 0 and 180 degrees, or equal to 180. So it looks like 180 is going to be what we're looking for. That's the angle that corresponds to the y value of -1. So theta has to be equal to 180 degrees. Okay, so we found that cosine inverse of -1 is equal to 180 degrees. And now on to part 2 of the problem. Part 2 is to find what we're looking for, tangent of cosine inverse of -1. And cosine inverse is 180 degrees. We just found that. Cosine inverse of -1. So now we have to go to the tangent curve. And by the way, we can actually show, we can draw this curve if you want to see it. So cosine is -1 here at 180 degrees. It's kind of tedious having to draw all of these values there, but that's what that would look like. Now tangent 180 degrees, that's a different curve. Tangent is going to look like this, something like that. So 180 is actually going to be right here, and you can see that the y value of the point on the red curve is 0. It goes right through the x-axis, so the answer to that one is 0. So there you go. And by the way, we have these asymptotes whenever you're dealing with the tangent curve. Now again, you can refer back to the shape. You don't have to rely on my less than inspiring drawing of the graph. Okay, so let's try one more of these before you try one on your own. Again, the most important thing to remember today is start by finding the value of the inside expression. The problem is we don't know what that notation means. So in order to help us understand what it means, we're going to set it equal to theta and then convert. This is the button that we would push on our calculators to find the angle in this situation here. So now we know what we're looking for. We're looking for the theta values. You can plug into the secant function that will give you 2. So when secant is positive, you have a triangle in the first quadrant and a triangle in the fourth quadrant. So the reason I know that is because secant is the hypotenuse over the adjacent side. Hypotenuse is always positive, so the adjacent side must be positive. And this side would be x, negative x root 3, and this side would be x root 3. So you probably recognize this ratio, 2/1, as a 30, 60, 90 degree triangle. So the angle opposite x root 3 is always 60 degrees. So our reference angle is 60 degrees. The angle in the first quadrant would be 60 degrees, and the angle in the fourth quadrant would be 300 degrees. So theta can be 60 degrees or 300 degrees if we're looking for the angle measures between 0 and 360, but we're not looking for the angle measures between 0 and 360. We're just looking for a value for secant inverse of 2. So we're not trying to solve an equation necessarily. We're just trying to find the value of this expression. This is considered to be the output of a function. So if you look at the range restrictions for secant inverse is restricted to values between 0 and 180 degrees. So we're going to cross out the 300, and we're going to say that secant inverse of 2 is equal to 60 degrees. Okay, so on to part 2. Now we're going to find cosecant of secant inverse of 2. And we know secant inverse of 2 is 60 degrees. And so now we just have to find secant or cosecant 60 degrees. So to do that, let's draw a triangle in the first quadrant. This is a 30, 60, 90 degree triangle. Cosecant 60 degrees is the hypotenuse over the opposite side. X's cancel out, and we're left with 2 over root 3. Multiply both sides of that fraction by root 3, and we get 2 root 3 over 3. And there you go. So I want you to take a picture of these 2 pages here, and also take a picture of these 2 pages, and I'm going to give you one more chance to take a picture of the range restrictions at the left, and also the basic trigonometric graphs at the right, and this basic information here. Now you're going to try number 5. So remember, the most important thing to know today is when you start these problems, begin by finding the value of the inside expression. The problem is we don't know what that notation means. So what we have to do is set that expression equal to theta and go from there. So try number 5, and when you come back, we'll do it together. Okay, we're back. If that equation is true, then by definition, this equation must be true also. And so now we see what we're looking for. We're just looking for the angle measures that make the sine function equal to 1 over root 2. So now we can draw some triangles, and sine is positive, so it's going to be in the first and second quadrants. And you probably recognize that triangle, or that ratio, that is a special ratio. And the reference angles are 45 degrees. And so we have 2 angle measures that work between 0 and 360. 135 degrees and 45 degrees. But one of these angle measures is not going to be our answer. We're looking for 45 because that's within our range restrictions for the sine inverse expression. So we found that sine inverse 1 over root 2 is actually equal to 45 degrees. That's part 1 of the problem. We found the value of the inside expression. But now we're going to find the value of cosecant of sine inverse of 1 over root 2. Well, we already found the value of the inside is 45 degrees. So now we just have to find cosecant 45 degrees. So 45 degrees is a special angle. So our reference angle is 45 degrees. This is a 45, 45, 90 degree triangle, obviously. So cosecant 45 is the hypotenuse divided by the opposite side. X's cancel out, and we're left with root 2. So if you got that answer, excellent. If you had some trouble along the way, that's okay. But try problem number 6, and remember, always start by finding the value of the inside expression. So try number 6, and when you come back, we'll do it together. Okay, we're back. So we want to find the value of the inside expression, but we don't know what that notation means. So we're going to set it equal to theta. And remember, that's the notation you would use if you have an equation like so. You're trying to find the angle measure. So this equation tells us what we're looking for. So let's find those theta values. Cosine is positive in the first quadrant and the fourth quadrant. So I know it's positive because cosine is the adjacent side divided by the hypotenuse. So the adjacent side must be positive for both these situations. And of course this other side is x and negative x. And x is the side opposite the reference angle, so the reference angle must be 30 degrees. And so one of the angles is 30 degrees, and the other angle is 330 degrees. So theta is equal to 30 degrees and 330 degrees if we're looking for the measures between 0 and 360. But we're not looking for those angle measures, we're just looking for the value of cosine inverse as a standalone expression. So cosine inverse of root 3 over 2 is equal to 30 degrees. So now we can go on to part 2 of the problem. We're going to find what the problem is actually asking, the value of secant of cosine inverse of root 3 over 2. Now we found cosine inverse of root 3 over 2 is 30 degrees. We found that in the first part of the problem. So now we just have to find the value of secant 30. So if the reference angle is 30 degrees, and that means that this side must be x, this side must be x root 3, and this side must be 2x. So secant 30 degrees is the hypotenuse over the adjacent side. And the x's cancel out. We're left with 2 over root 3. And if we want to rationalize the denominator, we can multiply both sides of the fraction by root 3. And we get 2 root 3 over 3. So if you got that one right, perfect. Good job. Go ahead and try number 7. Remember, the most important thing to consider today is that when you do these problems, find the value of the inside part of the expression first. Go ahead and try number 7. When you come back, we'll do it together. Okay, we're back. We want to find the value of the inside expression, but we don't know what it means. So we have to consider that this is the button that we would press in our calculators when we're trying to find the value of an angle in this that satisfies this equation. So by changing the form of this equation to this, we can see what the problem is actually asking. So cotangent, we need to figure out where cotangent is 0. So let's draw the cotangent curve. You have those curves right in front of you. Cotangent repeats as all the graphs do. My graph is not going to be perfect here, so don't expect it to be perfectly drawn. We have asymptotes. And we want to know where cotangent is 0, and you can see that it's 0 in a lot of different places. But 90 degrees is the part we care about. That's where Well, that's in the range restrictions for the cotangent inverse curve. So theta is going to be 90 degrees, and therefore we found cotangent inverse of 0 is 90 degrees. So that was part 1 of the problem. Now we have to find sine of cotangent inverse of 0. So that's the same thing as sine 90 degrees because we found cotangent inverse of 0 in the previous part of the problem. But now we have a collapsed triangle. This represents a quadrantal angle. And so we need to go to our basic curves. Whenever you have a collapsed triangle, it's easier to use the curves or the graph of the trigonometric functions. So this is what the sine curve looks like. If you look at the your page there, and 90 degrees is here, and that's when the y value equals 1. So sine 90 degrees is 1. So if you got that right, perfect. Okay, go ahead and try number 8. Remember, the most important thing is when you start trying to find the value here, we want to begin with the inside expression. Find the value of the inside expression. Try number 8. When you come back, we'll do it together. Okay, we're back. We want to find the value of the inside expression, but the problem is we don't know what that notation even means. So we're going to set it equal to theta, and this is the button that you would push in your calculator if you were trying to solve this equation. So now we understand what we're looking for. So let's draw the triangles. Cosecant is positive in the first and second quadrants. And you probably recognize this ratio corresponding to a 30, 60, 90 degree triangle. The hypotenuse is always 2x. Cosecant is hypotenuse over opposite, so the opposite side must be x root 3. And that's how I know that the triangles are in the first and second quadrants, because root 3 has to be positive. 2x is always positive. And then this side would be negative x, and this side is x. So 60 degrees is always opposite x root 3. And so now we're ready to find our angles. 60 degrees is the first angle, and the next angle is going to be 120 degrees. So theta can be 60 degrees or 120 if we're looking for the measures between 0 and 360, but we're not. We're looking for the value of cosecant inverse 2 over root 3 as a standalone expression, which means it can only be one value. It's the output of a function. So cosecant inverse of 2 over root 3 is 60 degrees. So we found the value of the inside expression. So now we're going to find the value of cosine of cosecant inverse of 2 over root 3. We already found cosecant inverse of 2 over root 3. That's 60 degrees. So this angle is 60 degrees. And the opposite side must be x root 3, adjacent's x, hypotenuse 2x. Again, this is a 30, 60, 90 degree triangle. So cosine is the adjacent side divided by the hypotenuse. The x's cancel out, and you're left with 1/2. So if you got that right, excellent. Okay, so now we're going to go to some slightly different problems. In these problems, the reference angle is not going to be the actual angle. So other than that, they're going to be pretty much the same type of problem. So remember, the most important thing today is to start by finding the value of the inside expression. The problem is we don't know what that notation means, so again, we're going to set it equal to theta. And remember, that's the button you push in the calculator if you're trying to solve this equation. So this tells us what we're actually looking for. So let's draw some triangles. Cotangent is negative in the second quadrant and the fourth quadrant. How do I know that? Well, cotangent is the adjacent side of the reference angle divided by the opposite side of the reference angle. And in these situations, the legs of the triangles have to be opposite signs. So for example, this side has to be negative x root 3, and this side has to be positive x root 3. This side has to be positive x, and this side has to be negative x. So you see we have opposite signs in each scenario. And of course, this is a 30, 60, 90 degree triangle. Now the reference angle is opposite x, so the reference angle must be 30 degrees. And one of our angles is 150, and the other angle is this angle here, which is 330. So the reference angle was 30 degrees, but neither of our actual angles that we found are 30 degrees. We found that 150 degrees works and 330 degrees works. Now 330 is outside of the range restriction for the cotangent inverse function. If you're looking for the angle measures between 0 and 360, there's two of them. And in fact, there's an infinite number of solutions to this equation, but we're just looking for the value of cotangent inverse of negative root 3 as a standalone expression. So we found that cotangent inverse of negative root 3 is equal to 150 degrees. So now on to the part 2 of the problem. We're looking for cosecant of cotangent inverse of negative root 3, and we found that cotangent inverse of negative root 3 is 150 degrees. So now we have to find cosecant 150 degrees. So that angle is going to terminate in the second quadrant, and if we subtract 150 from 180, we get a 30 degree reference angle, which means that this side must be x, this side must be negative x root 3, and this side must be 2x. It's a 30, 60, 90 degree triangle. And cosecant is the hypotenuse divided by the opposite side, which reduces to 2. So that was just a slightly different problem. Let's try another one of those. So again, we're going to start by finding the value of the inside expression. That's part one of the problem. But we don't know what that notation means, so we're going to set the expression equal to theta to help us, because this is the button that we push in our calculator when we're trying to solve the following equation. So by converting this equation to this form, we can now see what we're trying to find. We're trying to solve that equation there. And so cosine is negative. So that means that we're going to have a triangle in the second quadrant and a triangle in the third quadrant. And this is a x over x root 2 triangle. So our sides are going to be x and negative x and negative x and negative x. And the hypotenuse is going to be x root 2 because we recognize this as a 45, 45, 90 degree triangle. The reference angles are 45, of course. And this angle is going to be 135 degrees, and this angle is going to be 225 degrees. Notice that our angles are not, neither of them are equal to the actual reference angle. So theta is going to be equal to 135 degrees or 225 degrees if we're looking for the measure of angles between 0 and 360. But we're not doing that. We're just trying to evaluate cosecant inverse as a standalone term. It's considered the output of a function, and the output of a function can only have one value. There's only one value for the output given one input. So that means that cosine inverse of negative 1 over root 2 is equal to 135 degrees, because cosine inverse is restricted to numbers between 0 and 180 degrees. So now we can find the value that we're actually looking for, sine of cosine inverse of negative 1 over root 2. And we found the inside part is equal to 135. So now we're just looking for sine 135 degrees. So we're going to rotate all the way to 135. So we have a triangle in the second quadrant. And if that angle is 135 degrees, then the reference angle is 45 degrees. And obviously we're dealing with a 45, 45, 90 degree triangle. So sine is the opposite side divided by the hypotenuse. X's cancel out. We're left with 1 over root 2. And if we want to rationalize the denominator, we multiply both sides of that fraction by root 2, and we get root 2 over 2. So there you go. All right, so again, the difference of these problems is that the reference angle wasn't the actual angle we were looking for. So that happens when you have a negative ratio in the cotangent or cosine inverse or secant inverse expressions. So take a picture of these problems, and I want you to try number 11, and when you come back we'll do it together. Okay, we're back. As usual, we need to start by finding the value of the inside expression, but we don't know what that notation means. So we're going to set it equal to theta, and remember, this button is what we use in the calculator if you're trying to solve this equation. So what we're really trying to do is solve that equation. So that equation corresponds to two triangles, each in the the second quadrant and the third quadrant. And so these are the two triangles we're dealing with. And you may recognize 2 over 1 as a special ratio. And the adjacent side is 1, because this is 2 over 1. And of course, we're dealing with a 30, 60, 90 degree triangle. And the reference angle is 60 degrees here, and 60 degrees here. So that's 120 degrees and 240 degrees. So theta is equal to 120 or 240. 240 is outside of the range restrictions for secant inverse. Theta must be between 0 and 180 degrees. So secant inverse of -2 is equal to 120 degrees. That's part 1 of the problem. Now we have to find tangent of secant inverse of -2, but we just found secant inverse of -2 is 120. So now we just have to find tangent 120. So let's draw a triangle. 120 would be about there. And the reference angle is whatever 180 minus 120 is. That's going to be 60. And the side opposite 60 in a right triangle is going to be x root 3. And this side is -x. So obviously we're dealing with a 30, 60, 90 degree triangle. And tangent is the opposite side divided by the adjacent side. X's cancel out, and we have -√3. So if you got that one right, perfect. So use number 11 to help you with number 12. Remember, you're going to start by finding the value of the inside expression. Try number 12. When you come back, we'll do it together. Okay, we're back. So we're going to start by finding the value of the inside expression, but we don't know what that notation means. So we're going to set it equal to theta to help us figure out what it means. And remember, that's the button you push if you're trying to solve the following equation. So this equation tells us what we're looking for. So cotangent is negative in the second and fourth quadrants. And if cotangent is 1, we're dealing with an x over x ratio. So you may recognize this as a 45, 90 degree triangle. The reference angles are all 45 degrees. And the actual angles are 135 degrees or 315 degrees. So theta is equal to 135 degrees or 315 degrees. So cotangent inverse is restricted. The values must be between 0 and 180 degrees. So cotangent inverse of -1 is equal to 135 degrees. So cosine of cotangent inverse of -1 is the same thing as cosine of 135 degrees, because we found that inner part in the first part of the problem. And now we just have to find cosine 135 degrees. So we're going to rotate that angle there. That's a 135 degree angle, so the reference angle is 45. And we're dealing with a 45, 45, 90 degree triangle. Cosine is the adjacent side divided by the hypotenuse. The side adjacent to the reference angle divided by the hypotenuse. So the x's cancel out. We're left with negative 1 over root 2. And if we want to rationalize the denominator, we multiply both sides of the fraction by root 2. So there you go. Okay. If you got that one right, excellent. So now we're going to go to some problems where the inside angle is actually going to end up being negative. So that red part there, the inside part, is going to be a negative angle. Otherwise, it's really the exact same problem that we've been doing. So remember, always start with the inside expression there. We're going to find the value of the inside expression. But we don't know what that notation means. So we're going to set it equal to theta. And that's the button you press when you're trying to solve this equation. So now we see what we're actually trying to find. So cosecant is negative in the third and the fourth quadrants. You probably recognize this as a 45, 45, 90 degree triangle. And so the reference angles are 45 degrees, and the actual angles are 225 degrees, and this angle is 315 degrees. So theta is equal to 225 degrees or 315 degrees. But this is going to be a slightly different problem because neither of these angle measures work. Our cosecant inverse expression has range restrictions, and neither 225 nor 315 actually work. And again, if you want to see the range restrictions, just go to your graphs. Here's the graphs. Cosecant is restricted. You can see by looking at the graph, or you can see by looking at the inequality here. Cosecant must be between, cosecant inverse must be between negative 90 and 90 degrees. So, what do we do here? We don't have an angle that we can use. Well, what we're going to do is rotate in the clockwise direction. And the angle we're looking for is actually negative 45 degrees, because that angle is coterminal with the blue angle. It stops at the same place. The blue angle goes counterclockwise and stops at the green part there. But notice if you rotate in the pink negative 45 direction, that's going to be clockwise, and you end up at the same green terminal side of the angle. So they're coterminal. So again, the restriction for cosecant inverse is it has to be between negative 90 degrees and 90 degrees, not including 0. So our answer is actually going to be negative 45 degrees, the pink angle there. So that was kind of a tricky problem. The value of cosecant inverse of negative root 2 is actually a negative angle. So now we go on to part 2 of this problem. As usual, cotangent of cosecant inverse of negative root 2 is what we're looking for, and we found the inner part is negative 45 degrees, and you should always use parentheses when we have a negative inside a trigonometric function. So I found that that inner part is negative 45 degrees, and now we just have to draw a triangle. We're going to rotate down because it's negative 45 degrees. And I can use that same pink angle so we remember where we got that. And of course the angle is 45, so we have a 45, 45, 90 degree triangle. And cotangent is the adjacent side divided by the opposite side, adjacent to the reference angle divided by the opposite side of the reference angle. So x over negative x, which is just negative 1. So in this problem, we actually had a negative angle that we had to deal with. Okay, let's do one more of these problems before you try one on your own. Again, we're going to have a negative angle here where you see the red. So we're going to start by finding the value of the inside expression as usual. But we don't know what that notation means, so we're going to have to set it equal to theta. And again, this is the button you push in your calculator when you're trying to solve the following equation. So now we understand what we're looking for. We're looking for the theta values that will give us negative root 3 over 2. So sine is negative in the third quadrant and the fourth quadrant. And sine is opposite the reference angle. Opposite the reference angle over the hypotenuse. And this side is negative x, this side is x, negative x root 3 and 2x. And the angle opposite x root 3 is always 60 degrees, so the reference angle in both the triangles is 60 degrees. This actual angle is 240, and this other angle is going to be 300 degrees. So theta can be 240 degrees or 300 degrees, but neither of these angles are in the range restrictions for sine inverse. Sine inverse must be between negative 90 degrees and 90 degrees. How do I know that? Well, it says on those pictures that I had you take at the beginning of the class. So neither 240 nor 300 work. Instead of rotating in the blue counterclockwise direction, we're going to rotate in the pink clockwise direction to negative 60 degrees. And that's actually the angle that we're looking for. That's the range restrictions for the sine inverse curve. That's just what mathematicians have decided. So what we found is that sine inverse of negative root 3 over 2 is equal to negative 60 degrees. That's the first part of the problem. So now we need to find what the problem is actually asking for. The value of cosine of sine inverse of negative root 3 over 2. And we found the value of sine inverse of negative root 3 over 2. That is negative 60. So now we're just trying to find the cosine of the negative 60 degree angle, and so we're going to rotate. We're going to rotate down into the fourth quadrant. And you probably recognize this as a 30, 60, 90 degree triangle. X root 3 is always opposite the 60 degree angle. And so cosine is the adjacent side over the hypotenuse, so x over 2x, which is 1/2. So I want you to get a picture of these two pages, and you're going to do a problem like this now. So try number 15. Remember, always start by finding the value of the inside expression. And remember, this inside expression in these particular problems is going to be a negative angle. So don't get fooled by that. All right, try number 15. When you come back, we'll do it together. Okay, we're back. So again, we're going to start by finding the value of the inner expression, but we don't know what that notation means, so we have to set it equal to theta and then convert it to this equation. Now we know what it's actually asking us. So tangent is negative in the second and the fourth quadrants, and you may recognize that ratio. Tangent is opposite over the adjacent side. And the reason I know it has to, the triangles have to be in the second and fourth quadrants is because the signs have to be opposite for the legs of the triangles. And the angle opposite x is always 30 degrees, so that's our reference angle. Our actual angle starting with is 150, and the other angle is going to be 330 degrees. So theta is equal to 150 degrees or 330 degrees, but neither of those angles are actually in the range restrictions for the tangent inverse function. Tangent inverse has to be between negative 90 degrees and 90 degrees. So instead of rotating in the blue counterclockwise direction, we're going to rotate in the pink clockwise direction. That's going to be negative 30 degrees. So theta is actually negative 30 degrees. So tangent inverse of negative 1 over root 3 is equal to negative 30 degrees. So we're done with part 1 of the problem. We found the value of the inside expression. So now we're going to find what we're actually looking for. The cosine of tangent inverse of negative 1 over root 3. And we found the inside part is negative 30 degrees. We did that in the first part of the problem. And now we just have to find cotangent negative 30 degrees. So we're going to rotate down 30 degrees into the fourth quadrant. So that angle is negative 30, and this is obviously a 30, 60, 90 degree triangle. So cosine negative 30 is adjacent, the adjacent side over the hypotenuse. And so that simplifies to root 3 over 2. So there you go. If you got that right, excellent. Okay, try number 16. Remember, the inside part is going to be a negative angle. And always start by finding the value of the inside part. So it's going to be a negative angle inside there. Try number 16. When you come back, we'll do it together. Okay, we're back. So we want to find the value of the inside part, the red part, but we don't know what that notation means. So we have to convert it, set it equal to theta, and convert it to sine theta is equal to negative 1 over root 2. Now we understand what the problem is actually asking. It's asking for the angle measures that make that equation work. If sine is negative, then we're going to be in the either the third quadrant or the fourth quadrant. And you may recognize this as a 45, 90 degree ratio. So this side is x, or that side is negative x, negative x, x, negative x. And the hypotenuse, of course. And so the angles we're looking for are 225 degrees. And the other one is 315 degrees. So theta is equal to 225 degrees or 315 degrees. But neither of these are in the range restrictions for the sine inverse function. Neither of them are. So what do? Well, instead of rotating in the blue direction, we rotate in the this pink direction, which is negative 45 degrees. That's a coterminal angle with the blue direction. So theta is actually going to be negative 45 degrees. So what we found is sine inverse of negative 1 over root 2 is going to be negative 45 degrees. That's the first part of the problem. But what we're actually looking for is cosecant of sine inverse of negative 1 over root 2. And we already found sine inverse of negative 1 over root 2 is negative 45 degrees. So all we have to do is find cosecant negative 45. Because it's negative, it's going to rotate down into the fourth quadrant. A reference angle is obviously going to be 45 degrees. And of course this is a 45, 45, 90 degree triangle. And cosecant is the hypotenuse divided by the opposite side. And that's going to end up being negative root 2. So if you got that right, perfect. Okay, so notice in this next problem we have functions that are inverses of each other. We have the cosine function and we have the cosine inverse function. And so something special is going to happen, but let's just do this problem as we normally would do. We're going to find the value of the inside expression first by setting it equal to theta. And we're going to translate that equation. And we see what we're looking for is theta when the cosine ratio equals negative 1/2. So we can draw some triangles. Cosine is negative in the second quadrant and the third quadrant. And cosine is the adjacent side divided by the hypotenuse. That's why I know that the triangle is going to be in the second and third quadrants. The opposite side, of course, is x root 3. In this case, negative x root 3. So we recognize this as a 30, 60, 90 degree triangle. 60 degrees is always opposite x root 3. That's the reference angle. So the angle we're looking for is 120 degrees or 240 degrees. So theta is 120 or 240, but 240 is outside the range restrictions for the cosine inverse function. So theta is going to be, well, cosine inverse of negative 1/2 is going to be 120 degrees. So on to part 2 of the problem. Now we're going to find cosine of cosine inverse of negative 1/2. And we know that inside part is 120 degrees. We just found that. And so now we just need to find cosine of a 120 degree angle. So that's going to be over here. And of course the reference angle is 180 minus 120, which is 60 degrees. The side opposite 60 degrees is always x root 3. So it's a 30, 60, 90 degree triangle, and cosine is the adjacent side divided by the hypotenuse. X's cancel out, we get negative 1/2. So what is different about this problem? We just did the same exact problem that we did before. There's really nothing that we see that's different. But remember, this function and this function are inverses of each other. They're both cosine. We have cosine and cosine inverse. This number was negative 1/2, and our answer was negative 1/2. So what you're going to find is that when you plug in a cosine inverse function into a cosine function, you're just going to get whatever that number is. And it's the same with all other functions. Here we have cotangent of cotangent inverse. That's just going to be 1. Here we have cosecant of cosecant inverse of 1. That's just going to be 1. So I want you to try numbers 20 through 22. Notice that the yellow and the blue and the green, they're all inverse functions. So you should be able to find the answers in about 8 seconds. So try 20 through 22. When you come back, we'll do them together. Okay, we're back. So negative 1/2, 0, and root 2. Again, we don't have to do all the math because these functions undo each other. And we're just left with whatever the numbers are inside. Now, you're going to see expressions like this where that's not actually true, but we're going to deal with that in the next class. When you have an inverse function on the outside and a regular function on the inside, then it's not always going to be true. Sometimes it will, but it's not always going to be true that the expression is going to be equal to whatever is inside. But we'll deal with that in the next class. Okay, we're going to do a few more problems here. So it says, write an equivalent expression for each problem below without trigonometric notation. When they say trigonometric notation, they mean sine or secant inverse. We're going to write an expression representing this thing here without sine and secant inverse notation. So I know that sounds pretty strange, but we're going to do this the same way we did the previous problems. We're going to start by analyzing the inside expression. So we're going to set it equal to theta, just like we did in the previous problems, and then we're going to translate. If that equation is true, then by definition this equation must be true. Now it says up here we're assuming that x is positive. So when we draw our triangles, they're always going to be in the first quadrant for these particular problems. If x is positive, then that means this ratio is positive, so secant has to be in the first or fourth quadrants. But theta cannot be in the fourth quadrant because the secant inverse function is restricted to values between 0 and 180, so it has to be in the first or second quadrants, not the fourth quadrant. So that limits our triangle to the first quadrant. That's going to be the case with every problem that we do from now on in the class. The next 5-6 problems. The triangle has to be in the first quadrant. That's why it says assume that x is positive. This just simplifies things because it can get a little complicated otherwise. So it says that secant theta is equal to 1 over x. This angle here is going to be theta, and tells us secant theta is equal to 1 over x, so secant is the hypotenuse over the adjacent side. So I'm going to assume that 1 is the hypotenuse and x is the side adjacent. So now let's move on to part 2 of the problem. Now we're going to find sine of secant inverse of 1 over x, but that's just equal to sine theta because we set secant inverse 1 over x equal to, we set it equal to theta. So believe it or not, all we have to do is just use the triangle to find sine theta, and then we're done. So this problem looks really scary, but it's actually easy. So sine theta is just the opposite side divided by the hypotenuse. The only problem is we don't have the opposite side. So how do we do this? Well, let's move this stuff down here. I'm going to move this graph over here so we have enough room to use a Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared is equal to c squared. And I'll let a equal x and b will be the side that we're looking for. And c will be the hypotenuse, it's 1. So then we have x squared plus b squared is equal to 1. And then we're going to subtract x squared from both sides. And we get 1 minus x squared. And then we're going to square root both sides, so b is equal to, and remember, whenever you square root both sides of an equation, you have to write a plus or minus symbol. So b is equal to plus or minus the square root of 1 minus x squared, but this side is above the x-axis. We know the triangle is in the first quadrant, so that means b must be positive. So we can write what b equals up here, the missing side, and now we can find sine theta. That's just equal to the side opposite over the hypotenuse, so root 1 minus x squared over 1, and that just simplifies to root 1 minus x squared. So that is the answer. Again, this is assuming that x is positive. If it were not positive, we'd have some other issues we'd have to deal with. So let's try another problem. Remember, start by analyzing the inside part of the expression. So we're going to set that inside part equal to theta as we normally do. And if that's true, then by definition cosine theta must be equal to x. And now we're going to draw a triangle, and the triangles are always going to be in the first quadrant because of the reasons that we discussed earlier. Now you can write this x as x over 1, and then we know that the adjacent side is x and the hypotenuse is 1. Again, in this case, the hypotenuse ended up being 1. We're going to label this angle theta. And in part 2 of the problem, we're looking for cosecant of cosine inverse of x. And we defined cosine inverse of x as theta. So we're just looking for cosecant theta. The only problem is we don't have the opposite side. But we did this math over here. We can just copy that. It turns out it's going to be the same math in this particular problem. That's not always going to be the case. But it's the same math, so we can copy that. And we see that the missing side must be root 1 minus x squared. So cosecant theta, looking at this triangle, is going to be root 1 minus x squared, actually 1 over. Cosecant is the hypotenuse divided by the opposite side. So 1 over root x, or root 1 minus x squared. Now we could rationalize the denominator, but that's really not necessary for these types of problems. I don't want to complicate things. So there you go. There's another problem like that. So there was a lot of similarities there. Okay, let's try one more of these before you try one on your own. So again, we're going to start by analyzing the inside part of the expression. We'll let theta be equal to tangent inverse of 1 over x. And if that's true, then by definition tangent theta is going to be equal to 1 over x. And now we can draw a triangle. The triangle is always going to be in the first quadrant because x is positive, so tangent is going to be a positive ratio, which means it must be in the second or third quadrants. It can't be in the third quadrant because that's outside the tangent inverse range restrictions. So it's got to be in the first quadrant. And the angle we'll just call theta, and tangent is opposite over adjacent. So the second part of the problem is going to be to find cotangent of tangent inverse of 1 over x, which is the same thing as cotangent theta because we define tangent inverse as theta. So now we're just looking for cotangent theta, and we can use this triangle to help us. Cotangent is the adjacent side over the opposite side. So in this case, we don't even need to use a Pythagorean theorem. We know cotangent is simply x over 1, which is x. And there you go. So we didn't need the Pythagorean theorem for that one. So I want you to take a picture of these problems here and use 25 to help you with 26. You're going to set the inside part equal to theta and then translate just like we did in the previous problem. So try 26. When you come back, we'll do it together. Okay, we're back. So we're going to set the inside part equal to theta, and we're going to translate to a different form of the equation. And now we can draw our triangle. It's going to be in the first quadrant because x is assumed to be positive, which means that sine is going to be equal to a positive ratio, so it must be in the first or second quadrants. But the sine inverse function, it's this angle, which is what sine inverse is equal to, must be between negative 90 and 90. So that restricts the triangle to the first quadrant. So we'll make theta green there. That's the angle there. And you can write x as x over 1. So the hypotenuse is going to be 1 and the opposite side is x. So now, in the second part of the problem, we're looking for tangent of sine inverse of x, but we defined sine inverse of x as theta. So all we're doing is looking for tangent theta, which is the opposite side over the adjacent side. The problem is we don't have the adjacent side of the triangle, so we're going to have to use the Pythagorean theorem. So we can let x equal a, and c is going to be equal to 1. And we're going to subtract x squared from both sides, and then we're going to square root both sides, so we get plus or minus root 1 minus x squared. And we know that b has to be positive, because again the triangle is in the first quadrant, so this side must be positive. So now we're ready to find tangent theta. That's just the opposite side of the green reference angle divided by the adjacent side, and you're done. We could rationalize the denominator, but it's just not something that we're going to worry about with these algebraic expressions. So if you got that right, excellent. Go ahead and try number 27. Remember, you're going to set secant inverse of x equal to theta and translate and draw the triangle. When you come back, we'll do it together. All right, we're back. I'm going to set secant inverse of x equal to theta. And by definition, if that's true, then secant theta is equal to x, which we can write as x over 1. And then we're going to draw a triangle. The triangle has to be in the first quadrant. That's going to be the case for every triangle in these problems. It has to be in the first quadrant. And the reason for that is secant has to be, if it's positive, because x is, we're told x is positive, so it has to be in the first or fourth quadrants. But the angle can't be in the fourth quadrant because secant inverse is restricted to angles between 0 and 180. So that isolates the triangle to the first quadrant. So secant is the hypotenuse over the adjacent side. And in part 2 of the problem, we're looking for cosine of secant inverse of x. But we define secant inverse of x as theta. So notice we have secant theta is x. If we want to find cosine theta, well, that's just the reciprocal. You just flip it around. See, cosine is the adjacent over the hypotenuse. So that's just going to be 1 over x. So in this case, we didn't have to use the Pythagorean theorem. Alright, so if you got that right, good job. If you had a little trouble with that, that's okay. These problems can be a little intimidating, but with some practice, you'll get better at this. Try number 28. When you come back, we'll do it together. Okay, we're back. So, as usual, we're going to set cotangent inverse of 1 over x to theta. And by definition, if that's true, then cotangent theta is equal to 1 over x. And then we can draw our triangle, which is always going to be in the first quadrant because x is assumed to be positive, and the cotangent inverse function is restricted to values between between 0 and 180. So we'll make this angle theta, and we're told that cotangent theta is 1 over x, so that's the adjacent side over the opposite side. And we're looking for secant of cotangent inverse of 1 over x. But we defined cotangent inverse of 1 over x as theta. So we're really just looking for secant theta. We can use the triangle to help us. The problem is we need the hypotenuse for the secant function. So we need to use the Pythagorean theorem. So A can be 1, B can be x, and C we don't know. So we have 1 plus x squared is equal to c squared, and then square root both sides. I get 1 plus x squared, square root 1 plus x squared is equal to c. And the hypotenuse is always going to be positive. So then we can write that expression up there, square root of 1 plus x squared. So now we're ready to find secant. Secant is the hypotenuse divided by the adjacent side. So our answer is square root 1 plus x squared. So if you got that right, perfect. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3 and number 4 and number 5 and number 6 and number 7, number 8 and number 9 and 10 and 11, 12, 13, and 14. But don't go before you get the homework. Here's the first couple pages of the homework. Get a screenshot of that or a picture with your phone. And screenshot number 2 and number 3, number 4 and number 5 and number 6, and you have the answers at the right. So get that homework done completely, correctly, neatly, and keep it in order in your binder or your digital notebook. And I'll look forward to seeing you in the next class.